Hi, welcome to Database Internals series where we'll deep dive into database architecture, different types of databases. The distinction could be basis different things. Why I wanted to do this is because before making any design choice or before making any choice when it comes to databases, right? If you understand things from the get-go, it can help you to make the right choices. And we'll start from the beginning, which is what does a database system architecture look like. Now the thing is, different databases have different uh, choices, design choices that the architects have made. That is primarily because they are optimized for different use cases. What we'll be doing in today's video is we'll go through whatever the common themes are. These common themes would exist across, mostly exist across all different types of databases, and this will lay down the foundation of database internals, right? So today primarily we'll just be going through DBMS architecture. What are different communication, what are different blocks, and what are they responsible for. So yeah, plan is to enable you to think from a design first perspective and then take decisions from that point. Okay, so typically database management systems use a client server model. The client is your application and the server is your DB nodes. Uh, these instances are typically referred to as nodes. I'm sure you're already aware of that. Before we jump on to the architecture, there is no common blueprint when it comes to DB architecture, as I mentioned, because different types of databases are optimized for different use cases, right? So this will be there, but what we'll do is we'll demonstrate the common themes across different databases. Also, the architecture that I'll present you, right? These components that will be there in the architecture, the boundaries between them could be like slightly blurred and hard to see and define. Um, the primary reason for that is because these components are maybe coupled for tightly coupled in the code for performance or any other reason, right? So to segregate these components and then define can get slightly harder. I'm sure if you go through the source code of different databases, you'll understand it. But again, to come back to the point, we'll try to demonstrate the common themes across different databases. Okay. So let's jump right into it. This is what a typical database architecture looks like. It has four aspects to it. You have your transport subsystem, then you have your query processor, you have your execution engine and storage engine. So let's go through the flow and then we'll keep coming back to this architecture to derive insights. So typically this is what the flow looks like. The client requests arrive through the transport subsystem, which essentially has two parts to it. One is cluster communication and one is client communication. So whenever your query comes, right, it is being handled by client communication. Now, why do we need cluster communication? Because your query, it may need to talk to other database instances or nodes. That is why you have two parts to it. One which is responsible for cluster communication and one which is responsible for client communication. So requests obviously come in the form of queries. This is the language which databases speak. Transport subsystem does communication with other nodes, which is typically taken care of by cluster communication block. Transport subsystem hands over the query to query processor, and query processor consists of two parts. It has a parser and it has an optimizer. What does parser do? Obviously, it parses, interprets, and validates the query. Query optimizer is responsible for coming up with the execution plan. The optimizer comes with a lot of execution plans and picks the best available plan basis certain conditions. We'll discuss those in the coming videos. But high level view, optimizer optimizes the query and comes up with the execution plan. So there can be two types of execution again. One is remote execution and another one is local execution. Local execution is going to happen in that instance which received the query, and remote execution if the instance needs to communicate to other instance, to other node, it will happen via remote execution. So writing and reading data to and from other nodes is taken care of by remote execution. And local queries, of course, are executed by the storage engine, which is the next part. So if you see, storage engine has a transaction manager, a lock manager, access methods, which control the access patterns, You have a buffer manager, which is responsible for caching, and then you have a recovery manager. Okay, so as I mentioned, transaction manager schedules transactions and ensures that the transactions cannot leave the database in a logically inconsistent state. What that means is whenever you get a transaction, it should always be in a consistent state. It could be with respect to what data is present in different nodes or other parameters as well, right? Moving on to lock manager. So this essentially is responsible for thread safe operations. So unlike, I'll give you one example. Redis is a single threaded in-memory database. However, a lot of databases are multi-threaded and they require for thread safe concurrent operations. Lock manager is responsible for doing exactly that. It ensures that these operations do not violate physical data integrity, right? So high level, just this is the gist, right? Then you have your access methods, manages access and responsible for organizing data on disk. This could be managing the indexes, which we store in B trees, heaps, or whatever's there, right? Moving on to buffer manager. So this essentially is responsible for data pages in memory. So now what are data pages? Again, will come in the subsequent videos for this series, right? So yeah, and then recovery manager, whatever operation has happened, right? So this, if you would have used GCP or AWS or any of these cloud providers, you usually can do point in time recovery. Recovery manager is responsible for doing exactly that. It stores the operations, transactions, logs, and it's responsible for restoring the system in case of a failure to a previous point in time, right? So essentially this short gist is what I wanted to provide you with, where you know that okay, these different components exist in a database architecture and which component is responsible for what. This will give you a blueprint to proceed further, where what you can do is you can go through any database and its particular architecture and then see which part is responsible for communication, which part is responsible for optimizing the query, execution, and then how it is taking care of the indexes, storing data in the database, exactly, right? All these aspects it would take care of. So now essentially you have a common theme blueprint which enables you to understand databases at a deeper level, right? So yeah, this I think is pretty much it for this time. I'll see you in the next one. Thanks a lot.